In an amateur radio antenna system, a counterpoise acts as an artificial radio frequency ground. It is essentially the other half of an unbalanced antenna designed to complete the electrical circuit for RF currents when a true highly conductive earth ground is either unavailable, impractical, or too lossy. To understand why it is necessary, it helps to look at a balanced antenna. A standard dipole has two equal halves that balance each other out, giving the RF current a complete path to flow. However, unbalanced antennas like quarter wave verticals, unfed half wave antennas, or random wire antennas only represent one half of that circuit. The counterpoise provides the missing half. When your transmitter pushes RF current into the antenna element, an equal and opposite current must flow into the ground system. Without a counterpoise, the system will try to find a ground anywhere it can. This usually means the RF current travels back down the outside of your coaxial cable's shield. With a counterpoise, the RF current flows efficiently into the counterpoise wires instead of your feed line, radiating the signal outward rather than back into your equipment. It is a common misconception that driving a copper rod into the dirt provides a good RF ground. While an earth ground is essential for lightning protection and electrical safety, dirt is actually a very poor conductor of RF energy. A counterpoise is an elevated or insulated network of wires, radials, placed above the soil to create a highly conductive capacitive coupling with the earth, acting as a much more efficient mirror for the RF waves. A good counterpoise becomes especially critical in a few specific scenarios. Low band operations 80 meter and 160 meter. Operating on the lower HF bands often involves physically large vertical antennas or inverted L configurations. Because soil is lossy at these wavelengths, laying out a network of quarter wave wire radials, the counterpoise, is critical to achieving a low SWR and ensuring your signal actually radiates rather than warming up the dirt. Preventing RF in the shack. If you are running a 100 watt linear amplifier into a random wire or an unfed antenna without a proper counterpoise, the returning RF current will travel down the coax shield directly into your transceiver. This can cause distorted audio, erratic behavior in digital modes, or even damage to sensitive homebrew SDR equipment. Portable operations. When operating temporarily from a balcony or in the field where driving ground rods is impossible, a single quarter wavelength wire simply laid on the ground or hung from the radio's ground terminal serves as a highly efficient counterpoise. The ideal length of a counterpoise wire depends on the antenna type. For a quarter wave vertical, the counterpoise wires, radials, are typically cut to quarter wavelength of the operating frequency. For unfed half wave antennas, a much shorter counterpoise, often just 0.05 wavelengths, is usually sufficient to stabilize the matching transformer and keep RF off the feed line.